Section 7.2 brings us to matrix algebra. So let's start with addition and subtraction. That's pretty straightforward. So we're going to learn just addition and subtraction here, and understanding that when you add two matrices, they need to be exactly the same order. That means the same size. So this one, for example, is a 2 by 2, and this one's 2 by 2, which means we can add or subtract those. This one, or C, is a 1 by 4. Remember, it's row by column. And D is a 4 by 1. These are not the same order, even though 4 times 1 is 4. But a 1 by 4 is not the same order as a 4 by 1. So C and D you could not add or subtract. So in fact, we can cross off B right now, because I can see that C and D cannot be added because they are not the same order. So this one is undefined. Whereas A and C, part A is okay because B and A are the same size. Part C, those I can add because A and B are the same size. And D, well, let's see, A is a 2 by 2 and D is a 4 by 1. So this one also is undefined because they are not the same order. All right, but let's do part A and part C. So let's do addition and subtraction. So for part A, we're looking for B minus A. So let's see. B is the matrix 2, 3, -4, 0. And A is -4, 0, 1, 2. So here's how we do it. Here's our definition. We have two matrices of the same size, and each element is the sum of the corresponding parts. So row 1, column 1 has a 2 here. I subtract the negative, oh shoot. Did I do that? Yeah, I did that right, okay. B minus A. So this is my B, and this is A. So I take my 2 and subtract the element that's in the corresponding position, row 1, column 1, and I will subtract them. So I get B minus A equals 2 minus -4 in that row 1, column 1, which gives me a -6. And I do that to each part, so then I get 3 minus 0, gives me a 3 in row 1, column 2. And then our -4 and 1 correspond, so that gives me a -4 minus 1, gives me a -5. And then finally the 0 minus 2, which gives me a -2. So there's A. B we decided is undefined because C and D are not the same order. C, for part C, I'm doing A plus B. So you'll notice I didn't really need to write this down. I can look at these right here and kind of subtract the parts. Same with A and B. So I could actually add these parts just looking right here. And what I'll do is I'll color code it. So let's do my matrix first. So I know it's going to be a 2 by 2. I add the same sizes, and I end up with the same size. And let's see. So I have row 1, column 1 added to row 1, column 1. So -4 plus 2 gives me a -2. And then row 1, column 2, that's 0 plus 3. So that's going to give me a 3. And row 2, column 1, 1 plus -4 gives me a -3. And row 2, column 2, 2 plus 0 gives me a 2. And there's C. So that is addition and subtraction with matrices. They have to be the same order in order to be added or subtract, otherwise you'd say undefined. All right, another straightforward operation is scalar multiplication. So not to be confused with matrix multiplication. We'll do matrix multiplication in the next section. Right now, I just want to talk about scalar multiplication. That's a little more straightforward. So here on this recording, we'll perform scalar multiplication. We'll do matrix on the next one. And I want you to notice, no, that's actually for the next recording too. Scalar multiplication. So if I have a matrix, m by n, then I can multiply by any scalar. So a scalar is just a single number, just a single constant, so k. K is any real number. Then this product, k times a, so k is a number, a scalar, whereas A is a whole matrix. So A is capital A, it's representing a matrix. So every element of that matrix will be multiplied by that scalar k. So for example, if I have 3 times this matrix, then I do 3 times every element. So the 2 becomes a 6, the 1 becomes a 3. It's multiplying every element by 3. 3 times 3 is 9. 0 times 3 is 0. 0 times 3 is 0. And 4 times 3 is 12. So there's scalar multiplication. So in exercises 17 through 30, you'll take both of these straightforward applications. We have addition, subtraction, and scalar multiplication. So let's practice a couple of these. So C plus D, I'm adding these two guys together. So I know that I have a 3 by 3. This is what am I thinking? 3 by 2 and a 3 by 2. Those are the same order, so that means I can add or subtract them. So adding them together, I know I'm going to end up with the same order, so that'll be a 3 by 2 again. And I add the corresponding elements. So 0 plus 2 gives me 2. And then 1 plus negative 3 gives me negative 2. And then the 2 and the 0 gives me 2. And the negative 1 and the positive 1 gives me a 0. A 3 and a 4 gives me 7. And a 1 and a negative 2 gives me a negative 1. So that's 18. Now subtracting, so we want A minus B. A is a 2 by 3. B is a 2 by 3, which means I can subtract them. They're the same order. And it also means I'm going to end up with the same order, so I'll end up with a 2 by 3 matrix. And I just subtract the parts. So A minus B. So that's negative 1 minus 0. 3 minus 2. 0 minus 1. 2 minus 3. 4 minus a negative 2, so that's plus 2. And a 1 minus 4. And there's number 20. And for 28, we're looking at negative 2 times b, so I'll erase my marks on b. I can do scalar multiplication to any size matrix, so I don't even concerned about the size, but I'll end up with the same size. So if I start with a 2 by 3, then I will end with a 2 by 3. So multiplying each element by negative 2. So 0 times negative 2 gives me 0. 2 times negative 2 gives me a negative 4. 1 times negative 2 gives me a negative 2. 3 times negative 2 gives me a negative 6. Negative 2 times negative 2 gives me a 4. And negative 2 times 4 gives me negative 8. So that's 17 through 30 with some addition, subtraction, and scalar multiplication.